All right, welcome back to lesson 5.4. We are going to look at how to factor, but this time instead of just looking at problems where a is equal to 1, we're going to look at some problems where a is not 1, and we're also going to look at some special cases of factoring. So let's dive right in. So if a is not equal to 1, there are several methods that you can use to do this, but the method we're going to use is this. You're going to multiply your a and your c term. So a is the number in front of x squared, c is the constant at the end. Factor that like normal, but then at the end we're going to divide each constant by that a, and then move any denominator. This may not make a lot of sense right now out of context, but I'm hoping by the time we're done with these examples that you will say, oh, it does make sense. So here we go. All right, so here, in the last lesson, I told you that the first thing we should look for is a GCF, and that's just a good habit to get into. It's something that I can scan really quickly. I can say 2, 11, 12, no GCF. This one doesn't have an X. That took me all of 5 seconds. So just do a quick scan for a GCF every time. But since there's no GCF, what I'm going to do is take this 2 and multiply it by the last term. So I'm going to get x squared plus 11x plus 24. And now this looks like the problems that we were factoring in the last lesson. We're going to put 2 sets of parentheses and split up our x's. We need 2 numbers that multiply to 24 and add to 11. So that would be 8 and 3. And then this sign right here is a plus. So that means that they're both going to be positives. So I get plus and plus. Now here's the downside of this method. I have to remember that because I multiplied by 2 at the beginning, I have to now undo that. I can't just leave it x plus 8 and x plus 3. So I'm going to go back and divide by what I multiplied by at the beginning. Now 8 over 2 is easy. That's just 4. But over here, I get x plus 3 over 2. And this is where it said to move any denominator. This number here is going to move in front of the x. So my final answer is going to look like this. And if you multiplied by something at the beginning, you definitely need to have a number in front of your x, at least one of them, sometimes both of them. So that's kind of an easy way to check and just say number in front of x at the beginning, so number in front of x at the end. But this would be our final answer. All right. GCF check, 4, 7, 3. No, this one doesn't have an X, so that's no GCF. But I'm going to take this 4 and I'm going to multiply it by 3. Now, when I go to factor this, I'm going to draw my 2 sets of parentheses, split up my x's. What multiplies to 12 and adds to 7? 4 and 3. And then what signs am I going to use here? Because this is a positive, they're both going to be plus. So am I done? Nope. I got to go back now. Oh man. And I got to divide by what I multiplied by at the beginning. Let's switch it up. There we go. So since I divided by 4 at the multiplied by 4 at the beginning, I'm dividing by 4 now. 4 divided by 4 is just 1. But this 4 right here is going to move in front of the x, and we're going to get 4x plus 3. And that's all there is to it. So try this one out. Factor this, see what you get. So hopefully what you did was to multiply the 2 by the negative 9 to get negative 18. And then parentheses, x and x, multiplies to 18, subtracts to 7 would be 9 and 2. This sign here tells me that they are going to be different signs. And this sign right here is going to go with the bigger number. 9 is bigger than 2, so the plus goes here. And then the minus goes with the 2. So that would be, oh, that's not my final answer. See, I made the mistake. I got all excited about factoring. So now I need to divide by 2 and 2. This is going to give me 2x plus 9. Since I cannot simplify that at all, that 2 just gets brought right in front of the x. And then this one simplifies to 1. And that would be my final answer. All right, one more like that. Try this one and then check your answer. All right, here's what you should have gotten. So take a second, check your final answer. Does this match what you got, or did you get something different? If you got something different, where was your mistake? All right, we are going to move on. And we're going to look at some special cases. There's something called a perfect square trinomial, and it's in this form where we have a squared plus 2 times a times b plus b squared, or that could be the same thing, just the sign in front is a minus. And what's special about these is that we can factor them into a plus b quantity squared or a minus b squared. Basically, I'm going to say if I can take the square root of the first term and the last term, I need to check the middle term still, but there's a good chance that I'll be able to factor it in a special way. So like looking at this, according to our old method, what we would have done is multiply 4 by 9. Gotten 36. Two sets of parentheses, x, 6 and 6, both positive, and then divide by 4 at the end. However, my hope, and when I simplify both of those, when I simplify both of those, I would get 2x plus 3, 2x plus 3. And if you decide that this is the method that you want to stick with, that's fine. You do still need to recognize that if these are the same, it can be written like this. And you do need to simplify it completely to one set of parentheses squared. But my hope is that we'll get really good at recognizing special cases, and we'll go, wait a second, if I take the square root of 4x squared, I'm going to show more work than what I would expect you to. But if I take the square root of 4x squared, that's 2x. And if I take the square root of 9, that's 3. So if I check that middle term, if I do 2 times 2x times 3, do I get 12x? Well, 2 times 2 is 4, times 3 is 12. 12x, I do. So what I can do is follow this and say I'm just going to take what a is and b is and whatever the sign is. So it's my final answer going to be a, which is 2x, because I took the square root, whatever the sign right here is, so plus, and then 3, and then square it. Again, I want you to practice this method over here while we're in class. But if when it comes time for like a quiz or a test, you're like, you know what, I just feel better factoring using the methods that we've used before, that's fine. I will show you that actually this will be the shorter method over here. This is going to be our shorter method, and it's going to take you a little bit less time. So let's take a look. So I'm looking at this, I'm like 25, 81. Those are special cases. This would give me 5x. This would give me b equals 9. And if I do 2 times 5, I get 10, times 9 is 90, 90x, so that works. So I'm going to take a, this sign, and b, quantity squared. And that's going to take me a lot less time. And with numbers like this, it's going to save you a huge hassle, because who wants to do 25 times 81? Not me. So like I said, I want you to practice using this method, even though it might seem a little bit weird or uncomfortable at first. But there's another special case that we need to look at, and that's the difference of two squares. So the sum of two squares, or perfect square trinomial, was if we have a plus b written twice, a plus b and a plus b. Like here we had 2x plus 3, 2x plus 3. Now we're going to look at something where when we factor it, we get a minus b and a plus b. But it's going to look like this, where we only have two terms. So something like this. And what I'm going to do is still think about square roots. If I take the square root here, I get that a equals x. Square root here, b equals 8. So the formula tells me that what I'm going to do is draw my two sets of parentheses. A goes in the front, b goes in the back. And then no matter what, because this sign right here is a minus sign, they are going to be different signs. And that would be my final answer. The reason this would kind of work out is if I were to do FOIL, and multiply this back out, I would have x squared plus 8x minus 8x and then minus 64. But look here, those are going to cancel out. And so rather than writing plus 0x in the middle, they say, oh, we can just do x squared minus 64. So this should, when you see two terms and a minus sign in the middle, it should be a red flag to you, like, hey, there's something happening here. Warning, warning, something different's going on. So we're going to square root, and we get a equals 2x, b equals 7, and we're going to get 2x in the front, 7 in the back, and then minus plus. And it does not matter what order we put these in because it's multiplication of the parentheses. So I could also put 2x plus 7 and 2x minus 7. Either way, it's going to give me the same thing. So that is the rest of our factoring. We looked at factoring when a is not equal to 1, and then we looked at the two different special cases where we're looking at perfect square trinomials and the difference of cubes, different of squares. So if you have any questions, please let me know. I'd be happy to help however I can.